WACV 2022 presentation. My name is Lingyu. I recently graduated from Rensselaer Polytechnic Institute with my PhD degree. I worked with Professor Richard Radke. Our paper is about natural language video moment localization through query-controlled temporal convolution. So first, let's take a look at the objective of our work. The goal is to locate a short segment from a long untrimmed video that corresponds to a description presented as natural text. For example, here we have the query that someone walks through the door to enter the coffee house and put his hand on hips. We need to find a segment that matches this query. So I put a yellow text box here to show that this is the target segment that we need to find. And we also know that there can be misleading points. So here I put a red text box. You can see in these misleading frames, they also contain one key action, put hand on hips, but it doesn't have a previous action as walk through the door. So taking the neighborhood of each candidate frame is important. Besides that, we also find handcrafted metrics like cosine similarity or square distance may not be informative enough for finding a matching boundary when dealing with complex scenarios. Also, the query can either be related to visual content only or subtitle content only, or it can be related to both. Based on these challenges, we treated the video boundaries to be as similar as the edge pixels in the image processing area. The thing is that there are no silent segments that are self-distinguishable if we are not giving a query. Therefore, we need to learn a query-customized video boundary detector, which we call a query filter. So this is a little bit different from a typical image filter such as Localization or Sobol, or the randomly initialized filter in CNNs. So in our work, we convolve the constructed query filter with the given video and subtitle to get a boundary possibility response. The final prediction is generated by fusing the information in the video and subtitle together. Here are more details about our proposed model. We adopt existing pre-trained models to generate features and perform initial temporal encoding. We use bidirectionally LSTM to generate each element in a query filter. The number of the filter elements controls the size of the local video window that we would like to consider as a neighborhood. We perform convolution between constructed filter and the video subtitle sequences. At each timestamp, the response values from the visual and subtitle branches are fused along the timeline, and the temporal dependencies over a longer time range are captured. The final heat map indicates the probability for each frame to be a boundary. Here we visualize an example for the challenge 1, as mentioned before. We can see that all the neighbors around the boundary have a higher response because they together cover all the environmental constraints mentioned in the query, like entering the door and hands on hips. While the misleading point contains the action hands on hips, its neighboring points do not meet all of the constraints, so they all have a lower response. Therefore, by generating the position-aware query filter, our model produces good results for this challenge. Here we show the quantitative results on the TVR dataset. We claim that this one is the most challenging one, as 67% of the data contains moments with 2 or more actions. We can see that our model achieves higher ranking and mean IOU scores than existing approaches. More details on other datasets can be found in our paper. Thank you very much. Please let me know if you have any other questions about our work. Thank you.